Hello, everyone. My name is Tsvetelina Georgieva. I am a co-founder and executive director of DesignMorphine. Thank you so much for all of you who joined us here today. Our journey started back in 2014, and through it, we are able to connect with people from all over the globe, empower them, and fuel their passion for collaborative design. We had the privilege to have taught thousands of specialists and nurture their progress in some of the biggest companies in the world. DesignMorphine is a catalyst for collaboration with people who we admire deeply as individuals and professionals. Our team is comprised of almost 50 talented architects and designers and number of collaborating organizations, which gives us a multidisciplinary approach to design and its education across a gradient of applications. We are a community dedicated to academia, but all of us are also professionals and we practice our craft daily. This allows for great versatility. Some statistics in the next slide. We have taught more than 84 students from more than 84 countries all around the globe. We have traveled in so many cities and created different projects on many different topics. Our pedagogy surpassed the teaching of technical skills since we always challenge our students to give their best. First and foremost, we are a community, and as such, we support our students' dreams and we empower them. Many have been accepted to universities like Harvard, the Architectural Association, STIARC, and many more. Others started work at the accredited architects, Foster & Partners, BIC, Nike, Well the World, PlayStation, and other reputable offices. On the next slide, we may see some past examples of our students' work on multiple scales and topics like jewelry, architecture, installations, and many more. One thing always connects them, and this is the experimentation and unique workflows. As you can see, we are heavily invested not only in the virtual world, but also in fabrication. We also collaborate on product design with our partners, and one example that we see here is with Arturo Tedeschi. We created the suspension lamp called Horizon, which encapsulates a free-form 3D printed shape within a handmade glass shelter manufactured in Murano, Italy, and it was a part of Venice Glass Week 2020. In the heart of DesignMorphine is computational design, and it enables you to automate repetitive tasks, lets you prove your design decisions with real data, and forces you to think of design in terms of chunks of processes that can be used in many conditions. And the best part is that computational design is multidisciplinary and multi-scalar because it allows for this mindset to be applied across all industries of design. If we take it a step further into the fusion of multiple software and hardware and use them unconventionally, that's where you find the most breathtaking, truly innovative design ideas. And of course, if you are interested to learn more about DesignMorphine and what we do, you can always check our social media.
Thank you, Svetlana. Happy to introduce myself, Pavlina Varzilaki-Pryor here, co-founder and creative director of DesignMorphine. Super excited to be here with you all today to share some of the progress of our Master of Science in Computational and Advanced Design. We have two very exciting programs that are running in the current year. So basically we have a Master of Science, but we also have a PhD in Computational Design, which are both accredited and worldwide recognized by the University of Architectural, Civil Engineering and Geodesy, founded in 1942 in Sofia, Bulgaria. Our PhD offers 12 different pathways of innovation: computational architecture, AI, VR, metaverse, prototyping, smart cities, everything that is basically relevant to the future of design. Well, through our Master of Science, students get the unique opportunity to experience multiple really different industries like architecture, the metaverse, fashion design, industrial, interior, urbanism, vehicles, animation, robotics, all through the lens of computational design. As for the Master of Science that we have gathered today, like to learn a little bit more about, it is in Computational and Advanced Design program, and the mindset and techniques and software taught in the program can be applied to any creative field. And I think that that's what distinguishes it from really anything else. It's vital because it allows for great versatility and diverse professional experiences. And this is the third year that the program is running. And we have the privilege to be working with 32 incredible designers and architects and individuals from all corners of the world. The distinctiveness of the program lies in several key elements. As I said, it gives the unique opportunity to experience a multitude of different industries and really have this versatility and options, right? Like for one to change their industry or continuing, you know, like what they've had the opportunity to work on even before starting the master's. But it is an opportunity really to be flexible, right? Like in a time of rapidly like changing technologies and moving into different industries or like experiencing different kinds of design. It's quite liberating, I can say from personal experience. And also like it allows for great versatility and flexibility because it is crafted to be an online educational experience. And as such, it requires no additional really like expenses like model making or printing, with the only exception of the RoboLab, where students are creating their own swarm robots and RoboPets. We are applying our own accredited pedagogical methods and allow students to absorb information efficiently. And that's what we have been focused on with DesignMorphine for the past decade. DesignMorphine thrives at its teaching of new software. That's what we have been specializing. Especially like to people with zero experience. So even in the program, we have, I think, like more than 15 different softwares, and the students are really like diving into all of them, and they have like a really great understanding of them, like coming out of the program. Of course, computational design, it's a huge endeavor, right? Like, and as one specializes in one area, it's just a huge opportunity to learn and to grow your skills. But here, really, like students understand the differences between polygonal modeling, NURBS, subdivisions, like working with Grasshopper and Houdini, and generative design, computational design strategies, exposed to coding. So it's a very versatile environment. Like it just gives a lot of knowledge. And it builds up, right? Like it is a really like building a stepping stones with the knowledge that everyone is really like gaining throughout the whole process. And also like we have a huge team, 30 educators and mentors with real life professional experience from the best really companies and universities in the world. We have the privilege now that we have the third year to have a lot of our alumni also joining the team. And it has been really incredible because they get to pass on a lot of their wisdom from where they were students in the program now, really like, you know, also as educators. We have chapter presentations that will include our community, and I'll talk a little bit more about the chapters in a minute and what they mean. But basically, at least 7 times in the academic year, we include our community, and students and alumni have the opportunity to meet new people that, you know, like they're across the globe. They're actually in hiring positions, and a lot of times they've received the opportunities like even from those presentations that are still work in progress. And we're very proud, like again, like to have been working with some of our alumni. Others are, like in different industries, as I mentioned before, like they might be in companies like Nike, Wilder World, Mard Architects, Nagami, Aedas, Moonray, Sensory Orbit, Philly Beasley, Urban Art Projects, and others. And some alumni also have chosen to continue their educational journey at the AA, the Bartlett, the Angevante, UCL, or now even in our PhD in Computational and Architectural Design. And others also have created their own design firms, and they're, are continuing their firms that they had beforehand, like Nosales. But again, the most important part about DesignMorphine, I would say, and the masters itself, it is the disruptive nature, the fearless drive to build a united design community that is part of the growth and the pathway of each of these designers and architects and specialists path. The program is organized in a unique way. It's based in 5 leading design chapters and 5 supporting technical and theoretical labs that span over 9 months. The chapters are 6 weeks long, while the labs are around 1 week, and each chapter follows the following rhythm, really. In the first couple of weeks, we prepare for the design phase. So we have pre-recorded tutorials and one-on-one time with our core leads and tech leads like Eva Hefes, Tungengen, and Pedro Venegas Rodriguez, who are by the student side constantly throughout the whole duration of the program. Then moving into weeks 3 and 4, we have design studio, really like a phase where students meet daily for 4 hours per day, and their chapters leads are highly specialized in, the specifics that they're teaching. And also something that is unique here is that the educators who are advising on design, they all are masters really like of computational design, and they apply this daily into their work. So that's a huge difference. It makes a difference because again, it's the same person that could advise on, both sides, right? Like of design theory, but also about like the technical aspect. And in the next couple of weeks, 5 and 6, we have labs that like might occur or presentations where we invite our partners and community, and it's a great way to gain exposure like through these presentations. Well, labs now, like we have, like as we said, like the 5 chapters, we have 5 labs that are also intertwined into the program. The labs are really playing a vital supporting role for the chapters and are 1 or 2 weeks long and are strategically positioned to boost the students' performance during each chapter. Starting with chapter 1, I'll just give you a little bit of insights of what really like is each of these chapters. Chapter 1, really like we're working with what we're called prosthesis, and it's after our concept lab where we start with a scenario-based approach and envision the fundamental element, the human body, and the technical future this body will operate within. We're looking into cyborgs, half human, half machine, exoskeletons, augmented beings, and mutations. And here, as we're designing, we're also learning, right? Like in here, like our focus is Maya, ZBrush, and really like software that is used in the animation industry or, in companies like Zaha Hadid, Mad Architects, or even in footwear design. And this is really like the major stepping stone for the program because understanding polygonal modeling, how to build design, like it's absolutely vital. And then moving into the next chapter, chapter 2, that's where we're creating these living conditions and spaces that the body requires. We work with interior and exterior spaces and answer questions about ephemerality, mobility, adaptability, transformability. And this chapter is focused on component-based design and user interaction systems. And we have really like moving from polygons to interoperability with Rhino, NURBS, and SUBD, and Grasshopper. So that's the first step and venture into the world of really like more like computational design-based systems. And after this chapter, we have the opportunity to work with amalgamation. So that's really here, the objective is to conceive and explore the way that the core puzzles come together, they develop and create communities through clusters and aggregations. And it's the very question of what constitutes community of people. We bring the same scenario and design principles through the chapters. And here we're looking into the generation and optimization of rule-based structures. So we have parametric generative design with Grasshopper and generative design also with Blender this year. So depending on, you know, like the geometries and preferences, students can venture into both spaces. Next chapter, chapter 4, very exciting chapter, kinesis. We're working with vehicles and we're expanding into various complex structures which are weaved together by transportation and mobility systems. We're working with horizontal, vertical, underground, organic, based growth-based systems. And again, like here, Houdini, it's really like taking a very big, you know, like portion of, again, like the knowledge and like how we're building like the software skills as we're, you know, like using and applying them to really very innovative designs. We're learning about particle simulations and flows, and again, using like Maya and ZBrush. And the final stage is what we call cosmogony. So it's building a new world. And all these previous stages lead up to this stage, which we developed all assets and to the larger scales of these envisioned worlds, the city. And zooming out, of course, new challenges arise in terms of increased complexity and encoding behavior, which is our primary focus. And here students are working with C#, agent-based growth algorithms with Grasshopper, and they're venturing really like into coding in this space. As I mentioned, some of the labs, the concept lab is really like what we start with in the program. It's we're using now a lot of like AI in order to envision like some of the craziest stories. The students have the full flexibility and freedom to choose their own path and their own storylines. It's really like the concept lab is the connecting tissue of the master concept-wise, and it is an essential vertebra of the program. And it's creating this cohesive conceptual narrative across those chapters. And really the goal is for the students to develop a scalable conceptual framework and idea. And what this means is like even, you know, like though like we're starting with a concept lab, we're continuing like the conversations and the thought process about like how, you know, like creating this or envisioning a new environment and, you know, transcends or like what are the, how it impacts the human body. And then, you know, like moving into the next scales that I just talked about, like how it really impacts them. Another very interesting lab is the media lab, where we have visualization and graphics and how to produce stunning CGI images. We're working with rendering and post-production with Photoshop, and students are creating really unique styles and visualizations through this lab. Moving on to the prototyping lab, where we have, we're focusing really like on different kind of methods of prototyping, about like laser cutting, 3D printing, CNC milling, biotransforming, but really in the past couple of years, we've been focusing more on 3D printing and gaining an understanding of this like prototyping principles and optimization of the digital models. And the students submit a visualized basically version of their designs, and there is no real world model as an expectation, but we prepare the files if needed for any kind of exhibitions, or, you know, like if we need to print them, then like we basically do that part. The robotics lab, super fun, one of the favorites, I would say. It is part of the kinesis chapter. Students are building multifunctional small robots, or what's called swarm robots, and they are basically, like working with specific conditions and rules, sensors and sound, luminosity and movement. And it's very exciting because like basically like they act like little pets in the home, and even we've seen like the actual pets of some of the owners being very curious about like those little robots swarming around like the students' houses. But it does give a lot of great information, really, like this lab about like the basics of robotics, which again, like it is something that a lot of times it is needed, especially in installations. Virtual reality lab, very exciting one, and one that definitely takes a big portion of the program. We're integrating it even now throughout the whole process more and more, because like it does need a lot of understanding about optimization. Basically, after all chapters are completed, we focus on sharing these digital projects into shaping them into one experience. And in this lab, students learn to utilize Unreal Engine to turn their projects into interactive like VR models and make really amazing animations to demonstrate their concept. So it's really like from chapter 1 to chapter 5. So storytelling here is also a vital part of this lab. We also, like these are the 5 labs that were completed, but we also like had the opportunity to focus on collaborative design practices, and we wanted to share with you basically a glimpse of our New York student trip and into the Microsoft Garage. We also had the opportunity to meet in Italy with Pininfarina and in Sofia, Bulgaria, for the graduation of the students. So it was really like a great opportunity. We're looking forward to our annual meetup this year also, more to come on this information. But beforehand, like the stage here to Michael, I just want to say a couple of words about the application process. So again, like for the application process, there is no application fee. We have 2 scholarships available this year, which is they're both merit-based. We have Dream Boost and Dream Big. The deadline is the same, 1st of April. And we basically like with the 2 scholarships, what is important just to understand is that the requirement is to submit a portfolio, link to a website. But if you're applying for the Dream Big scholarship, which is basically like one applicant is getting like their full expenses covered for the program, that's where there is a design challenge about the gadget of the future. So that's where it's going to get like super interesting to see some of the ideas on that scale. While the Dream Boost scholarship has the potential to cover up to 30% of the student's educational fee. So I know that this is something that I'm getting a lot of question about like scholarships. So that's why I just wanted to say a couple of words about it. We also have, as you know, like 2 options about the program, like a 9-month or a 12-month program option. But this is really all based on credits. Again, like students are from all over the world with totally different experiences and paths of life. So it is expected that some might have more credits or less credits. But really the difference is in it that like after the program, which is absolutely unique, and the actually like the same for both the 9 months and the 12-month program, that after the 9-month program, we have like the students that need extra credits do an extra project. And this year, actually, we've had, we collaborated with Microsoft for this extra project. And it was super exciting because it was part of their annual hackathon. And yeah, like deadlines for applications are now, first one is early application in the 1st of February. And as I mentioned, 1st of April is for the scholarships. We do have another one during the summertime, so there is plenty of time for that. And also feel free to schedule one-to-one with me if you have any questions or you just want to chat about, life and design. I'll drop in like my calendar like on the chat, so whoever is like interested, wants to know about it, You don't need to prepare anything, just, whatever questions you have. I'm happy to meet new people. You guys inspire us and give us ideas and really keep us on our toes. And it all really comes from, like the knowledge and like what the needs of the future generation is. So thank you so much. I'm passing it on to Michael.
Hello, thank you, Sabrina. Thank you, Paulina. Welcome everybody. Always love doing these things to meet potential new students. Here. So this is okay. Okay, so yeah, so firstly, just want to go over a bit on our website. For those of you that might not be familiar with our website or how it works, on the main education page, you'll find the master's here and all its information. You'll also find PhD, and you'll find our webinars as well that are upcoming if any of you are interested in shorter term, educations and webinars. And then we have our other things here, design, we have all of our team, partners, news, and resources. Resources is a popular one. It has a bunch of free tutorial links. But let's jump into the master's program. So on the website here, you'll find all the information and description about the master's degree program. You'll find information about the credits, duration, deadlines, tuitions, scholarships, and all that fun stuff. You'll also find information here about the entire team of the program, and you can click any one of their names and find out more about them and things they've done and their credentials. And as Pavlina has already went into more depth, you'll see kind of overview of each chapter, and you'll see overview of each lab. And just to reiterate what Pavlina was saying, the way that this program works is essentially let's talk about when you're just starting. So when you're just starting, basically there's an individual design challenge, and then from there you would pick your teams, and there are teams of 3. So you would pick your teams, and this will be your team for the duration of the master's degree program. From there, you would go into a concept lab, and the concept lab is where you and your team, along with AI and meetings, will define what your kind of overall concept for the program will be and what you'll follow. Now, important to remember that we won't define your concept. The concept is totally up to you and your team, but throughout the course we will hold you to that concept. I think that's a very important thing to mention, right? So it's very important that you take the concept lab seriously and think about things that you want to work on. From there, you would move into the first chapter, which is prosthesis, which is, basically for the remainder of the program, you're working through these chapters and labs and building up this story and this world through the lens of computational design techniques, right? So the whole idea is that you're learning computational design, software techniques, and the kind of driver for that will be this concept, this story, so that you kind of know what you should be developing and working on. And it starts from the character and works all the way up to, the kind of world scale. So through the program, you're building the character, the objects, more intimate spaces, interiors, vehicles, transit, and then working your way up until you basically have this little world that you've created, with all the kind of necessary components, characters and things that this character interacts with in the world that they live in. So that's for the chapters, and then through after those chapters, you are or within those chapters, you're also introduced to these labs, which teach you important skills. Of course, there's the main concept lab, But there's also the media lab, which teaches you how to visualize your ideas, right? Like visualization is a really important aspect of what all of us as designers do. So it teaches you how to visualize those ideas. Prototype, which teaches you how to build those ideas in a physical, tangible aspect. Robotics, which is teaching you about programming these ideas. And then virtual reality, which is teaching you how to make an experience about these ideas. And that's pretty much like the way that this whole thing works. So the concept carries through all these stages, and you're building this kind of experience world through computational design methods and tools. Just to mention our partners, our partner university, the UACUG, for the with accreditation. We're also partnering with Microsoft, Logitech, Pininfarina, Chaos Group, Shapediver, PA, and Rhino. All of them are supporting us, all the time in different ways. And we're interacting with them, as Pavlina said, about like Microsoft, going there, visiting them, doing collaborations with them with the students. Same with Logitech, doing design challenges. Same with Pininfarina. Lastly, we went to Italy with the students there and did a workshop there, and it was a lot of fun. And the last part of the website is the Q&A, where you'll find a lot of useful information. As Pavlina mentioned, like if you want to talk more in depth or have some questions you want answered, you can check this first Q&A here, which also Pavlina put in the chat here, linked one-on-one, so you can meet and ask anything that you want. But there's a lot of important stuff in here where you can see past what places that students are working now since graduating. You can find out about the application process. You can find out about what kind of computer you should have, what kind of specifications you should have. You can find out about student licensing for software. So that's another thing, because it's an accredited program, so you get all the kind of student licensing for softwares through your student email and all that. And there's just a bunch more helpful information in here to check out. So now I want to move on to how does the program kind of operate. And what you'll see here is Teams. So the whole program kind of operates through two mediums, Teams and Miro. And in Teams, basically it's set up per chapter. So we have a channel per chapter, and we keep everything in that chapter and discuss in that chapter. And just to keep in mind that this is like 24/7. So usually someone's always available to help you whenever you need it. This program's kind of like an all hours program because everyone's in different time zones. So there's usually not any, like, as you can ask our students, there's usually not any kind of waiting for too long. If you need help with something, you don't understand something, you'd have some technical questions. So it's by chapter and by lab. And then also we have the chat where we have individual chats with each team, where we go more in depth about their project. And then of course it's a calendar here, which would have all your meetings, so you know when to join them and how to join them, and that. So that's kind of like where all the kind of conversation happens. But the main work happens in Miro, right? So in Miro, set up the same way by chapter and lab. There's a board for each chapter, board for each lab. Now, there's two kinds of boards that we have, which is a work in progress board and a finals board. And basically, through the entire chapter, you would be working in a work in progress board with your team. And basically, it's like every day you're working with your team, uploading new images, getting commented on by your educators and reviewers, and working towards the final. And then when you get to the end of that chapter, the presentation, you move on to the final finals board where you set up an actual presentation board, and that's where you would present that chapter from. If we look at the boards, for instance, we can look at the concept board, which is the first board you'd be working on with your team. You'll see it kind of looks like this, right? And there's kind of two sides. There's like the A side and the B side. That's because we have two different time zones available for students, and it's pretty much based on like where you're living and what your time zone is. So it's not really necessarily like a choice A, B. It's like there's two groups based on like where you're living. So we have people in like Europe, people in the US, people in India, people kind of all over the world. So that's why we have the two groups. But for each group, the tutors are the same, the educators are the same, and the interaction and the involvement is the same. And this is basically how a board works. Like you have your team and you do the work for that. So in this one, they're about building up their concepts and their stories. And that's pretty much like that for every single chapter. Now, if I go to, an important part of our teams is we have this links, right? And this would be where you would find everything you need in the program. Throughout the program, easily accessible. So like the Miro program, which we'll talk about, all the teams, the software you need, where to get it, how to get it, tutorials, rendering services, and all this kind of stuff you can you'll be able to have access to. Even a digital library provided by UACEG, which is an online library for the students. So first one I want to go into is tutorials. Right, so if I were to check out the tutorials Airtable, it would bring up this Airtable here, and it has all the tutorials that we have, and the tutorials here all have a link, and you go to that link, for instance, like this, and it would bring you to that specific tutorial of that chapter. And there's multiple tutorials per chapter, right? So here's the tutorial from Nicholas Turchi for chapter 1 prosthesis, right? So it's all laid out. It tells you what software you need for that tutorial, what kind of tutorial it is, if it's mandatory to watch, and also tells you when to watch it, right? Watch this one in Concept Lab, watch this one in prosthesis, watch this one in corpuscle, right? So it's all very organized and laid out right in front of you. The other one is the software, right? So this one here will tell you, it will tell you all the software you need for the course. Of course, it will be updated for next year. So probably this one, by the time your guys here will be Autodesk Maya 2025. But it'll tell you how to get it, what's the cost. Most of them have no fee because of the education license, and it will tell you the requirements to get the educational license and where to go to get it and how to get it. So all the instructions again there made simple for you to understand how to get the software, how to use your education licenses, and all that information. So you have kind of the software and the tutorials working together in Airtables. It's all laid out, very easy to follow, and very direct and specific. An important one is the program, which I'm not really going to go over in depth, but just to see it. Basically, the entire program of the course is laid out. And this tells you like when is their meetings, when is their off time, when is their presentations for each chapter and lab. So the way that each chapter pretty much works is that there's like 2 weeks of the beginning of the chapter, and that first 2 weeks usually is you watching tutorials, you coming up with the initial ideas. You'll probably meet with the leads of that chapter a few times just to check in and see how things are going. But there's no like official meetings with your educators of the chapter in those first 2 weeks. Then you have 2 weeks where you're meeting every day with your chapter leads. The leads are different for each chapter. And you're meeting for 4 hours each day with them, and that's basically where they go over and review the work. If you have any questions, if you're having trouble, pretty much like virtual desk crib. And so that's happening, every day for those 2 weeks. And then there's another 2 weeks where again it's without the main educators. It's more with your leads and your mentors. You're still working, and then in that last 2 weeks, you're kind of working towards the final, and then you have that last week where you basically build the presentation, and then you present, and then we move on to the next chapter and kind of repeat. And then throughout that, you have the labs, and the labs are a bit different because the labs will have a presentation, and they're shorter. So, but you're still meeting with the lead of that lab and kind of doing that work for the lab. Yeah, I think that's pretty much like the overall workflow. I just want to, before we move on, I want to just reiterate the importance of like just checking out the website, checking out the Q&A, because a lot of information is there, especially the computer, right? The computer's super important. You need to have the right tool for the job, right? Like, just like a doctor needs the right tool for the job. You need the right tool if you want to do this kind of work, right? So definitely check out all that. And I think, I think that pretty much covers how the program goes, how the whole kind of workflow of that goes. So I think we'll move on now to like talking a bit to the alumni, which Paulina will introduce, and then we'll move on to a Q&A where we can answer any questions. Oh, lastly, I forgot to mention one last thing. After the program, we have a Discord with all of our alumni. So since we're moving to alumni, we have a Discord with all of our alumni, a kind of like alumni secret Discord. So where we keep up with the students, we keep interacting with the students. We have a bunch of different things like tutorials and help, right? Like students are helping each other, and we're helping students even past the after they graduate. Career opportunities there. Whenever we or someone finds an opportunity for a career, it's posted there. Industry updates, and of course we have memes as well.
Memes is the most important part. Well, thank you, Michael. Thank you, Catalina. Yes, I would love to actually introduce our alumni that are here with us today. It's super exciting because we have our alumni from first year and from the second year that are joining us. And I would love to just, hear about how you guys are doing, what you have been up to, hear more about your endeavors and how, it has been for you. So after the program, during the program, I think it's quite valuable, to get to hear a little bit of your voice also. So today I'll give you the opportunity, of course, to introduce yourselves and what you do, who you are, how you use computational design, why this was important for you. We have today with us Samuel Carrillo Lacouture, we have Dylan Collins, Anthony Guiara, Ryan Lung, Kate Poroshenko, Oscar Olsen, Fatma Farag, Clark Cheng, and Laura Civetti. So yeah, like I'm super excited like to see your faces like from the summer or like before that, but it's really great. So thank you guys for joining us.
Yeah, so I think, let's just, jump in. I think you should call people. You should
I
call
should
people
call
out.
them out.
You should call them out.
That's stressful. No volunteers. I'll give it to the extroverts. First, I'll give the extroverts an opportunity to step up. No, we're an introverted group only. Okay.
I think most of us are introverts sitting behind the computer all day.
We're in trouble.
Well, Anthony spoke first, so I think we go with Anthony.
No.
That's it. It's done.
Yes.
Yeah. First
Tell
of
us.
all, it's nice to see everyone again. It's been a while. It's been a long time. Yeah. I mean, well, you were saying something, Mike. What do you want me to tell you? Tell me.
No, I was just saying, I mean, you're from the first year. How are you doing
Yeah.
afterwards? How did you enjoy the program? How are you doing after the program?
I mean,
What are you up to?
First, I want to say about the program, it's something I always keep thinking about. It was really amazing. Something that maybe I've said before, like when you enter this program, you really start to think differently. And I think you guys touched up on that when you were talking about computational design, about not being just knowing software, but it's really this mindset of thinking, a way of thinking about design. And that was something that really opened a lot of pathways in my brain, thinking about what is the intention behind something you're doing. So and the other stuff that we did later on. So definitely I recommend it to anyone who really wants to challenge themselves and really wants to kind of broaden their understanding about design and getting more into all this computational stuff. So it's really something I recommend in that sense. After the program, basically, Mike, you know that, and Pavlina and some alumni here know that I've joined the Wilder World team. So I'm currently now a procedural artist with under the wings of Oleg and Mike. We work a lot with Houdini mainly, but we still think in a computational way. We do a lot of computations and we solve problems, and we're actually using tools now that I don't think were designed. I mean, maybe they were designed this way, but like I personally come from a VFX background and I've used Houdini a lot, but I've never used it the way I use it right now after the program and after working with it this way. So currently we're working at Wilder World. I don't know if Mike, I'm sure Mike always sends teasers to the students about what's going on behind the scenes. But yeah, that's mainly what I've been doing. I also work a lot. Sometimes, I love here in Dubai. This is where I live. There's a lot of people who do a lot of interactive installations, so I have fun with that, and I use a lot of the computational stuff that I learned in the program to kind of come up with cool setups and stuff like that. But mainly, it's Wilder World building tools for Unreal Engine for the game designers there to like kind of build the whole world, because obviously they're building like Miami as it is. But yeah, it's been a fun ride and enjoying it a lot. So yeah, definitely looking forward to seeing also what I mean. I'm seeing every year how people are doing stuff from DesignMorphine, and it's really cool that now also there's a lot of AI. So it's exciting stuff.
Yeah, for you guys, like the first year where they have the AI option.
No, we didn't.
You had a real like Stefanos, like that was your AI, like the educator for the concept and theoretical lab.
Yeah,
That's
that was it. We didn't have the concepts, but it was nice. That's what I mean. Like we were able to come up with stories and then try to, translate them into visual narratives, and that was what's cool about it. So, but hey, It's
Yeah, we
changing now.
appreciate a lot of like you know, like the rigor that went into all this work, because especially the first year was like blindfolded. There was no information, or you know, like what, you know, like how the whole program like was imagined. Like we had guidelines, but we were also like open to then discovering a lot of new things. But yeah, thank you, Anthony, for sharing. You know, like we're very proud of like what the team is doing, like with Wilder World, like the whole generative design team, basically, of Wilder World, which is one of the metaverses that it's like still, you know, keep going on strong and like building like Miami, or like the digital twin like of Miami, like as you know, like playground, virtual playground. Like we have also like Eva, who is like part of this team, but the whole team is really comprised of this. So great. So yeah,
Thank you.
like since I'm passing it also like to Eva as your peer, and also she's in the program with us. She's one of the core leads. So I would love to hear from you,
Yes,
Eva, also.
seems like I've been a core lead for long, because you forgot to count me in the alumni now.
Yeah.
So I just want to say, like, even I was a part of the first batch, and it was like a really nice experience and journey for me. Like until now, I really credit the thinking that fueled in me because of this program. Like both for my passion and my professional thinking, like computational thinking, procedural thinking that I picked up from the program is really helping me in my professional background. As like Pavlina mentioned, I'm also working with Mike and Oleg and Anthony in Wilder World. And also like the good part, the best part actually of this program, which was even a benefit for us, like, okay, we did not had AI and stuff. And if you even have AI and stuff, you have the creative freedom to think about a world that you really want. Like you really want to design, that's like your world. You want the zombies walking under the water, or you want them flying in the sky. It's your world. So you are like an art director here. And that like, that's what something always was my passion, like thinking sci-fi, concept art, and having my own world designs and environment. So this is a program that really, you know, pushes you to design and control the softwares. Like think as and imagine as much you want, and you have like people here helping you out always, and you know, you like get the one-on-one guidance always. And also like being your core lead, I can also say that I'll be haunting you always, like all the chapters and throughout your designs I'll be there. And you would even have Pedro and Tung, like the core lead from other group, who will be with you guys as like your virtual team partner. Like we won't be like as educators, but more like your team members, because we'll see your designs from starting until the end. So it's like just shaping with them, like with a flow, with an organic flow. So yeah, I mean, I just want to say, like, I really had a fun ride during my masters, and I'm also enjoying as well, like seeing the program grow. So I can say like every batch has like a bonus brownie points, because there's something always new happening every year, and the last year students would be like grudging over it. Oh, we didn't had that. So it's always like plus points for the next years as they join. And if you're thinking about this program, I would just say in Ryan and Kong styles, join us. That's it from my side.
Is that a gateway for me to just talk? Like
We're calling out for you. Yeah, passing the baton, you know.
Yeah, I'm right now working like totally different things, like other than these guys here. Like they're like working in other works, dealing with all digital stuff. And right now after I graduated from DesignMorphine last year, I started working in Toronto with in Philippines Studio, where we make lots of interactive installations and sculptures that are made out of like modular blocks. Like essentially, a lot of these installations and sculptures are like made out of like polygons, like a hexagonal grid, or like spheres that are made out of hexagons and pentagons, like forming truncated icosahedrons, and are like polyhedrons. And like looking back at the master's degree, I think like the workflow is actually completely flipped. Like in real life, when we need to design a sculpture, we start by concept designing the whole thing, and then we dive down into the details and try to realize the whole thing by making it into chunks and then tackling them like module by module. But in the masters, it is actually a very great experience because we're starting from the smallest thing first, like the prosthesis, like the human being or cyborgs that is living in your world, and then you explore by going like one level up, up and up and up, and from the prosthesis to composite to the world. So I think like in master's degree it's really an amazing experience because like it is completely different from like what I'm used to. Where there's more space for you to just explore, and also with our amazing teammates and classmates, there's lots of cross-pollination of our creativity and culture because we all come from different backgrounds, and this master's being an online master's is it's really amazing that everyone is just around the world and we're experiencing different stuff in our own realities, and because we're merging together to form our projects, it feels really different just to join our different experiences together to form our own unique things. And just looking back at like last year, I still think that like the master is just I enjoyed it really, really much. I am out of words. Someone help me.
Pass it to somebody else now. You have the power
Fatma.
to choose who else like you want to like hear about like their journey, how they're doing.
Fatma, how are you doing? Are you still in the water?
Still underwater. I'm still stuck there.
You're still stuck. That's amazing.
It's always and forever. Somehow I'm always going back to the underwater. But like, yeah, what you were saying is like actually this really resonated with me as well because, well, I come from an architectural background, and it for the first time, I feel like in this master's, creating the like entire world building was something I've always wanted to do. And then I had the chance to do that, but like within a structure and with so many new tools that I've never used before. And like I always have these weird squiggly sketches that I could never really like make to come to life. But now I have that power, and now I also have the power to like also teach others to do that as well. So I'm kind of like all the knowledge that I kind of gained either from the tutors or from like the team leads or from my team, like not teammates because I was alone, but like with all my classmates, and especially in like Bulgaria when we all met, I learned so much in like these 3 weeks. It was amazing, like just like watching people like work and everything. I learned so much, and now I have the chance to like also pass that along, and I'm more on the academic or the research like spectrum. So I've actually included like I've introduced like poly modeling like to like my alma mater, like where I teach, and I'm also like also working with AI in different ways. It's not just generative or like for the creative process, just incorporating that into the workflow at different stages. I got to experiment in DesignMorphine, and I also get to do that with the students and my alma mater. So it's like really cool, you know, like this entire process. I learned so much, and I also looked at design in a very different sense because it was a very competitive, toxic environment before, but I enjoyed it anyways. Maybe it's like a thing, like a problem I have, but like in DesignMorphine, it was different, and everyone's learning from everyone. Like you have to like plug in like progress every day, but you also get to see how everyone else grows. That was just like mind blowing to me. It was just a completely different mode of learning and like even teaching and like just growing in general. So yeah, and now I'm working on like I'm writing up my dissertation for another master's, and I'm working in RD&D in like a corporate firm as well, but like just research, I'm trying to work with research and design, like all the tools I learned, but applying it in the real world and also in the academic world. So I'm trying to like experiment in these different, different directions. And thank you, DesignMorphine, for that. Can I choose now? Wait,
Thank you,
who's
Fatma,
here?
yeah.
Choose me that I'm running out of battery.
Okay, I'll choose Laura.
Hi, everybody. So nice to join you. Unfortunately, I chose a cafe shop to have this meeting, and it was a very dear. There was like Britney Spears songs and everything. I went outside. However, personally, do you hear me well? Yes,
Yeah, we hear you great.
nice. Personally, challenge master, really challenge master for myself. But absolutely, I really enjoy it, and especially all the connection between software, something that for me was a bit struggling. Using different software for one thing, like for your design, for me has been really powerful because you're getting the connection between them as I think the best things. Today I'm still a designer, connecting design with the fabrication. I'm working mainly in 3D printing with a company in Spain called Nagami. And I'm working a lot with Maya, I have to say. So thanks to them, to teach me and push me in this direction. It really helps me on modeling something that's more creative. And what more? Well, I don't have too much to say, but really great to have really happy to have made this decision, even if for me was a bit out of my it was out of my comfort zone, you know. I was meant to be more rational and everything have to be a function, everything to be in that box, and you learn to do out of the box. You learn to push everything, and also I think to make decision is the most thing that I learned. Thanks, guys. And happy to see. Where is the next meeting? Physical meeting?
Well, so soon to come information. Like we're just like working out like right now, like with Elena to arrange that. So yeah, that's gonna be super cool. Like if you guys like can make it also.
That's nice. Well, yeah,
Thank you,
all
Laura.
from my side. Thank you, guys.
Super exciting to hear how you're applying, like your knowledge, like to the, like more like tangible, like real life, like projects, because I know like we have the whole spectrum here from, metaverse and game design to really like exactly like manufacturing, right? Like totally different type of challenges. So yeah, it's your time to pick who is next.
Please. I have Clark in front of me.
Can you guys hear me? Can you guys hear me?
Yeah.
Yeah. So I guess I'll start off with I'm Clark, and as my name shows on Zoom, of course. I want to start off with, at least in the program, the way I structured it was I was fortunate enough to have my previous employer sponsor financially the degree as well. So that was definitely something that I was honored to have for sure, and be able to do the program because, I mean, I couldn't afford it. I mean, that's just how it is. But it was very challenging working full time and doing the program at the same time, for sure. It was a journey for sure, but I learned a lot, and it was a lot of the things that I kind of wanted to focus on at the end. And I realized that even after the program, and it landed me a lot of different opportunities as well. So I had a very strict regimen that I would do for the program. So the sessions would be from 9 to 12, and then I'd go to work at 2, and then end work at 9 p.m. Quickly get home and shower. After 9:30, I go to sleep for like maybe 5 hours, and then wake up 3 a.m. and continue that. So that cycle continued until the weekend. The weekend was, I could wake up at like 4 a.m., but it was a cycle. So I was pretty disciplined in what I needed to do and how I needed to do the work, and I figured out where I was like best focused and things like that. So working full time definitely is a challenge, but it's definitely possible. It's just like how you really structure your time and figure out what times you really are good at focusing in your work. Eventually, so after the program, I moved on to a different job now at UAP. So UAP does a lot of artwork and a lot of foundry work, kind of like what Ryan does, but we do the back end of it to make it real instead of conceptual parts. Sometimes we work with artists alongside, but a lot of these programs that we use in in DesignMorphine, whether it's Houdini and ZBrush or Maya, they all use as well in UAP as well. And when I interviewed for the position, I showed a lot of my work from DesignMorphine. They were super interested in how that can be applied into a fabrication point of view. So we actually started using Houdini, and they use ZBrush mainly for all their sculpture work and all their metal casting work that they do. But a lot of the work they want to try to see if they can make a lot of these procedural textures or these procedural models as well to help them out. So I'm kind of using Houdini in a way that's not, not for VFX or any of that. It can be used, but a lot of it is for like actual fabrication, actually like creating things. So a lot of 3D printed parts that we would use for casting. So a lot of it is experimenting with these type of softwares that we use to actually make things come to life for the artist and things like that. And then there's also the pragmatic things like in Grasshopper and Rhino for like shop drawings and, creating drawings for construction workers and things like that. So that's kind of how I see the program. I really recommend it. I think it's a very fun program. It's very, very rewarding program as well. And you get to see all the work that you've done. And you never know, a lot of people actually know the program. When applying to UAP, a lot of people would ask me how the program is, like they already knew it existed. So it's very popular. It's just a lot of people just don't talk. I guess a lot of people are introverts. So, but yeah, that's kind of what I think about the program and, how it can be applied. It's very versatile and you can really use it in a lot of different areas that you don't really think you could, but they're looking out for those type of skill sets as well.
That's a great perspective, Clark, especially again to hear how to apply it into a scope that it's outside of just, like a world building, right? So I think that's a lot of also the questions.
Physical world building.
Physical, yes, exactly. But we have a lot of people working in this realm, and I think that's where it's quite interesting. But yeah, thank you so much for sharing your story and your perspective. It was a very comprehensive answer, and also, you got the $100 million question: can I work and study at the same time?
Yeah, I thought I'd get it out of the way because I definitely did it. Yes, it's possible. It's just you just have to. I told you guys my schedule. Everyone's is different. Some companies are willing to work with you on times and things like that. It's just all about negotiating and all that. It's all about just talking to the higher ups and seeing what they want and what you want out of it and meet in the middle. So I didn't get to meet in the middle. It was just all 100-0 because I had no money. So it was all 100 or 0. So I had to go with whatever they decided at that point, which was fine because now I can wake up at 3 a.m. if I need to again. So I'm not used to that anymore. But yeah, so a lot of these programs you can really use outside of in fabrication, really unorthodox ways as well. So that's kind of where I saw how can these tools be leveraged in terms of creating things or making things come to life. And that's how I see it. So I use Unreal Engine too as well because we have to render for clients as well. And it's just really quick and easy. So it's a lot better than just using a standalone rendering engine sometimes. So.
Perfect. Thank you. Thanks so much, Clark. I'm curious also, I know Kate, also it's in the other end of the world. So maybe we'll give her the opportunity. Sorry, Clark.
Yeah.
Yeah, hello. I'm Kate, and I'm currently working at Med Architects as junior architect and in Beijing office. So yeah, it's kind of late for me. So my background was completely architectural before masters, and I'm really thankful to this program because it helped me to really open my mind how the design world is really versatile and can be much more than just, with this computational approach to design, the output can be unpredictable and so iterative, and it inspires you to be more experimental and search for new designs and opportunities. Yeah, and actually I learned a lot of useful software tools during the masters, which are not really typical for architectural industry. And currently that's really helps me at work, because the projects I'm currently involved in, like the architecture is really like natural like, and it flows like accordingly to the landscape. And so the output of your work as designer can be just the 2D drafting, as generally in architectural studios, at least from my previous experience. You need to have like more precise control over the model. So like there is like, I mean, I use Rhino and Grasshopper on daily basis, and like NURBS modeling, because for exact control, because some parts of this model can afterwards be used in the construction, maybe like for a concrete formwork, where like the aluminium facade panels, they will be bent after the model. You need to be really precise. Yeah, that's what I use in my practice currently. And like more personal output I get from the masters is to be more experimental and creative in design, because like all the software that you learned, you can feel really freedom in design, and I really enjoy it. So yeah, I really recommend the program, and thank you, DesignMorphine. Yeah.
Thank you, Kate. Thank you so much. I have a question for you. I know that the portfolio that like we're building, it's super, like innovative, and it's like out there. And I'm wondering exactly, like you applied like again, like to an architectural firm, right? Like, so what was their response? Like, how did they see like the potential exactly like of, like everything you've learned in how it applies like to, again, like the real world?
Oh yeah, they were really interested in because I also used like a lot of stuff from the program in my portfolio, and they were really interested because again, like I think that the models I have, like they're like tuned into their like philosophy of being like really soft and flowing, and currently there are quite a few people in the office that learn Houdini, and I think we might think of the way how implement it in the work, because currently it's mainly Rhino and Grasshopper, but I think it would be interesting to also implement Houdini to be even more iterative and experimental, because it's like that's what you need in architecture. There's always like updates from clients and asks for change and stuff, and the way you design it in Houdini is really useful for such things. Yeah.
Yeah. Thank you. It was great hearing from this perspective, like how you're using like your knowledge, and that you're enjoying your new endeavor like in Beijing.
Yeah, I really enjoy, like, except for one thing, that there is a lot of stuff in Chinese.
Yeah, time to learn Chinese now.
Yeah, in process.
Thank you, Kate.
Yeah. So I'll pick Oscar as my DesignMorphine teammate.
All right. Well, I mean, I'll talk briefly about it. Obviously, the program was really interesting. I got to work with Kate, which was really fun. And I mean, I think it really, to me, like the reason I went into the program originally was to sort of get more understanding of different types of geometry and how we can actually work with them. I came from a product/industrial design background, which means that it's like the design language often is very sort of square, and people are using like SolidWorks and Fusion and whatever, and it leads to kind of boring design outcomes, in my opinion. And so my goal with like picking the program was really to pick up more skills so I could do things that I found was more interesting in terms of shape and in terms of sort of ideation. And I think the program does open up that sort of mental capacity for you as well to be able to do those things. Having sort of the skills to know how to, get to those shapes and those geometries does make you think differently as a designer, and I think that's like a big plus. And then obviously I got to come back and teach chapter 2 along with Alejandro this year, which was a great experience. Getting that opportunity to kind of, from being in the program to being able to come back and help out and teach the next year, I think brings a lot. Having that sort of fluid as an organization as well, and like being that open to bringing in the students, does give us a lot of opportunities to sort of explore those pathways as well that I don't think would have happened in like a more traditional university setting, where maybe it's more stratified and like you don't get those chances much. So yeah, that's a bit of my journey, I'd say.
Thank you, Oscar. Like it was nice, like to hear like your perspective again, like from a totally like different like background, like coming into the program. Probably like for you, like it was also like a lot of like different programs that you've learned. But I know that like you were one of those that like was picking it up very, it seemed that like you were very well versed and like it was easy for you to really learn them. At least like that's how it looked like.
I mean, like I came into it not really knowing anything about the programs, right? Like knowing a tiny bit, but I think just coming in with a very open mind, and also like I think I'm the type of person who like likes to figure out why something isn't working when it's not working, and I think that helps for a computational design sort of career. That you don't, when something fails, you don't just go like, oh, it failed. You kind of try to look into it and try to figure out like why did things fail, and try to understand like how the geometry works like behind the scenes. And I guess that's a very different, there are some people on the course who are much more, I think, like who are much better at like the theories and coming up with like this like world building and coming up with all the ideas. And then I think there are people who are more technical. And I think the masters like bring those two skill sets together, I think is also a very interesting combination. Because I think both those types of people need each other to sort of make better work. You sort of complement each other.
Thank you so much, Oscar. It's really amazing, and it was really great to have you also as one of the educators this year, like in chapter 2, like again, like bringing your perspective and your experiences like to the program. I think it's been really great.
Yeah, thank you. It was great being there.
We can move on to Sam and Dean because I know like they're from the first year, so
go for it.
We have a couple of people from the first year. I know that it's been a couple of years, guys, like for you after the program, so you can tell us more about like like how it was for you, like the first year, and now like outside of that.
Yeah, sure. I guess I can go. Well, I mean, it was like a really interesting experience to be kind of like the guinea pigs of the beginning of the masters. It's very interesting to see how fast you guys continuously adapt to whatever is being developed or whatever is being used at the moment. Like from our year to the incorporation of like AI and things like that are very interesting. Just like how fast like you are like incorporating these things into a program and how it's enhancing it. Just seeing the work from all the people now is insane. But I think despite that, we had like a great time, a lot of things to learn. And I think it was a great opportunity to learn to design through multiple skills at the same time. I was an architect and I was working on the architecture field before that and kind of like focusing mainly in that. And it was very interesting. Well, first to have like the space to create a whole new world from the ground up and go through all the different skills, but also like to pay attention and changing the skills in which you are designing and incorporating like computational design techniques, which later on I never imagined so, but it ended up being very helpful because after graduating from the masters, I end up working in Nike, just designing footwear, which I never expected before I started that. So that was like very interesting as well. But yeah, I think those were like my main points. also like the quantity of exposure that you get like in the masters to like all these professionals. I think Paulina mentioned it already, but like all the people and critiquers that they invite to the end of every chapter is just like amazing, the feedback and connections that you make throughout the program as well.
Thank you, Sam.
Thank you, guys. I'll let you go, Dean.
Okay. Yeah, my name is Dean. I was also a first year for the DesignMorphine Masters program, and I also work at Nike. I think one of the big draws of the program for me was for undergrad, I studied fashion design, and I was looking for something that would open more doors to more disciplines. I think a lot of other students have the benefit of having studied architecture, and I think architects can get trusted to do more outside of architecture than someone who studied fashion design outside of fashion. So I was really looking to broaden my skill set. I had no 3D experience before the program, and yeah, just sort of broaden my horizons and explore and maybe figure out more of what I wanted to do. I ended up, now I do footwear, which I didn't land that far away from fashion design, but I used the programs that the master's program taught every day for work. So I think, you know, having this skill set has definitely opened my capability of like, if I want to approach a new project for myself or something career related, it's very much more approachable. And also, as Sam mentioned, and a lot of other people have mentioned, the network of other students and the professors and their expertise, and being able to have this network of people to talk to and consult and continue to learn from, I think is extremely valuable.
Thank you so much, Dean. Like from your perspective, like it was, yeah, it was quite interesting because like, again, you were like from a totally different industry, not really design experience beforehand. And I just like seeing like also like your path and how much like you've learned and how much like you just, you know, surrender to the program, like into like learning all these skills and feeling so confident and doing so well, you know, like after it, like it's really, you know, like it kind of like even from the first year, it gave me like a, you know, like a very good perspective that it's actually like working for people without this background also, and that you know, like things like to adjust and to make better. I just want to also like thank you guys for all the feedback that like you're always giving us about the program and being, you know, like so involved and so caring about it, because like as Eva was mentioning about the brownie points, they're actually like, you know, like we take into consideration every year's feedback, you know, like because like exactly like it's your voices that we're hearing, and we're modifying the program in order to become better and better every year. And it's your stories that inspire us to keep moving forward and, you know, like connecting to the next year and doing our best really like for everyone. So thank you guys. It does mean a lot. And I know that you're not like all here like to experience the changes like within it, but all the presentations like you can see like online and how, you know, the new alumni are doing, like definitely like we're thankful to you for that.
Yeah, thank you guys.
Amazing. I think that for the next phase, like we'll start with the presentations from this year, like for chapter 1 and chapter 2, like since we have like our current students with us, and then at the end of we'll have the opportunity like to answer any Q&A, like any questions that like you might have, like, and you know, like hear a little bit like more like of our current students. But yeah, thank you, alumni. Like, feel free to, you know, like stay with us, or if you have to run, feel free to also like go about your day. But it was really great to hear like how you're doing. We were very proud of you. So we'll have the first team like starting Hey guys, great to see you.
Hi, yeah, it's great to be
Hi.
here. Okay, so I'll start with sharing my screen.
Don't forget to introduce yourselves.
Yes.
Perfect.
Okay. Just curious, can I share sound? Because we have audio, but I think,
It may not work, but
yeah.
I think it's okay.
Okay. Right.
Hi, everybody. We are Group A1 and we are here today to present our project Cypher. And my name is Nisha. I'm a digital artist and an architect from India.
Hi, everyone. Thank you for being here. My name is Tala, and I have a background in 3D animation and virtual reality. And I'm based in Canada.
Hi everyone, my name is Josh. I have a background in landscape architecture and I'm based in Germany. Far ahead in the future, I am an entity unknown to you, speak to you, to tell you a story about a kind who's known for its resilience and extreme fanatism. This world is nothing like you've seen before. It's cold and it's dark, buried deep inside Hermes asteroid belt. Ammonia fog runs into the lungs of the beings living on it. Not known for its biodiversity, Nebulous is prone to very strenuous living conditions. Only the fiercest could survive these circumstances. Among them are the creators, known widely as the cosmic engineers. With the weakening life engines of the creators, they were ready to ascend into their shapeless forms and leave their home. But they were so attached to Nebulous, they didn't want it to suffer neglection. They gathered up their remaining strengths and from the oasis of life created a being they named Cypher. It was the ultimate obligation of Cypherzoans to protect, maintain, and improve the conditions of Nebulous. Little did they know what they had created.
As a resident of Nebulous, I dwell within my parents' pouch in a frigid ammonia-enveloped world, with temperatures ranging from -33 to -77 degrees Celsius. Life here adapts to ammonia's unique properties, using it to dissolve heavy metals and create robust structures from both flora and fauna. Life thrives underground, sustaining itself with carbide-based forms, and the landscape is marked by iridescent hues and shimmering ammonia oceans. Biodiversity is limited, but we, Cyphozoans, adapt through experimentations with diets and engineered structures made from microorganisms. Inside my parents' pouch, I ponder existence on this desolate terrain, while our civilization coexists with microorganisms, build underground cities, and seeks ways to endure the extreme conditions of Nebulous.
Cypher embodied resilience and adaptability, and this reflects in the design of their framework, equipped with a set of unique physical properties tailored to withstand but also replenish their celestial home. One of the most remarkable features of cyphozoas lies in their skeletal structure. Ammonia, acting as a potent solvent for many hard metals, cyphozoas boast a remarkable metal framework, which can be occasionally seen in their exposed bony joints. This robust feature facilitates their ability of temperature regulation between stark sub-zero sockets and heated underground cities, ensuring their mobility by protecting blood flow and safeguarding them from frostbite. Dense atmosphere and fog pose a significant challenge for most life forms, but cyphozoas triumph over this obstacle with an ingenious external respiratory mechanism located on its chest and biceps femoris. This skin, a porous marble, acts as a breathing apparatus that efficiently absorbs the minimal traces of oxygen present in the nebulous surroundings. Being absorbent in nature, residues embed themselves in the pores. In a process to dissolve these radicals, enzymes are released, which make these organs luminescent. To interact with an intricate network of fungal companion called BLOB blob, cyphozoas use their sensory tentacles, which are highly sensitive to motion, thus helping cyphozoas locate their prey, which is usually buried deep underneath the frozen ammonia surface.
In the unique world of cyphozoans, where they are facing a harsh scarcity of prey, a distinctive hunting and feeding strategy has evolved. They use a set of specialized tentacles with a powerful suction mechanism to capture and transport prey. To carry the weight of the tentacles, they are anchored to their chest by a bone-like structure. The captured prey is placed into bodily pouches on the cyphozoan's back, sorted by size for digestion and nutrient absorption. A network of connecting tissues links these pouches to nutrient-absorbing fibers, ensuring efficient nutrient extraction. Within these pouches, a slow and controlled digestion process occurs as the prey gradually disintegrates during their descent along the creature's back. Small veins secure the pouches and regulate their movement, ensuring an extended release of nutrients. These bodily pouches are vital for the cyphozoan's survival, allowing efficient prey digestion in their challenging environment.
I float in the milky and warm pouch in my parents' head, surrounded by the gentle embrace of comfort and nourishment, where I can overlook and see our harmonic environment. As I progressed through my growth stages from the initial blob-like form known as polyp, I began to develop faint hints of limbs, and my neural connections expanded beyond basic emotions, forging a deeper connection with my parent. The next phase, strabila, saw my neural network flourish even further, fostering profound emotional bonds with my parent. During this stage, my head grew larger, while my physical limbs remained in the nascent state. In the ultimate phase, ephira, my neural connections with my parent reached their full potential. Simultaneously, I started developing my arms, and my head continued to expand. It was in this stage that I stood on the brink of physical independence, as my parent prepared to release me into the environment for my full physical growth. Yet, as I grew into the ephira stage, a sense of deep fear overwhelmed my tiny being. I could sense danger in the air, a looming threat that our cyphozoan civilization might crumble in self-destructive chaos. The uncertainty of my future filled me with dread, and I clung to the safety of my parents, fearing what awaited me in a world on the brink of calamity. Thank you.
Thank you.
Thank you, guys. loving the project. It's a really unique one. I wanted to ask you guys, like, how do you feel about the program? How are you, like going now? You're like in chapter 3. I know, like, you're about to meet the new educators coming, like, as like your chapter lead, but being now through a couple of chapters and labs, like yourselves, like, like what has been something maybe that, like, was a surprise, like coming in, like how do you feel like your skills growing? I know you have like another, like you have some months ahead of you, like for graduating, but still, like, as like being in the process, I think that this is valuable to hear.
Yeah, I think for me at least, coming into this program, I was very excited. And honestly, till now, I'm super excited for each chapter. It's just the one thing that I really, really appreciate about this program is that with each chapter, it's like new softwares, new endeavors, and it builds on our skills from previous chapters. So it's a great learning experience, and like working with a team that's creative and putting our thoughts together and ideas together is super great skill to have, and I'm always looking forward to the next chapter. So yeah, it's great so far.
Yeah, one thing I could add is that I really like that there's more than doing just a master program. It's all about this network or family of DesignMorphine. So just knowing that there's someone who knows the solution for our problems is very nice. And I already learned a lot of nice people in this program, and this is something that's really nice in my mind.
Yeah, for me as well, the program has been wonderful, and coming from an architectural background and also being a digital artist, as an architect, I was always confined into thinking as the environment as slabs, walls, and floors, I had never done feature design, and this was our first feature design, and it was really fun and really wide and quite interesting way to explore new fields. And it's really interesting. And like Tala said, it has been a real pleasure to work with some of the tutors, and yeah, it's a great experience so far, and it's really exciting to be designing. Right now, we are designing a city for our creature, and it's really exciting to get inside the head of our creature and think about what it does and how it lives the life it lives and what it could require, and putting those things into functionally putting them into the city, and also learning new software. It has been incredible.
Amazing. Thank you guys for sharing like your, like your perspective. It means a lot to us. Like, I think it's a super fun project you're working with. Like, yes, get as much as possible into the head of this creature and make something absolutely crazy. No slabs, that's for sure. Thank you guys. We'll move on to the next team.
Go ahead and share my screen here for you guys. My screen share working correctly?
Perfect, thank you.
Great. Gina, would you like to open us up with your introduction?
Sure. Hi, I'm Gina. I am a graphic designer in Boston.
Well, my name is Alejandro. I'm an industrial designer based in Tijuana, Mexico.
And I'm Brady. I recently graduated with a degree in architecture undergrad from the Savannah College of Art and Design. And today we present to you the tale of a civilization known as the Viridians, a cyborg race from a distant world of Ekrondor. A trembling shadow fell over the loose rock and lava tremoring in the wake of current tectonic plates, shifting just yards away from where the Viridian Impey stood. As the cameras in the Viridian's eyes adjusted their focal range, the satellite sensors overhead blinked, fostering the transcommunication within the environment. Frightened, but only for a moment, the Viridian searched for Pei, his robotic companion. Reaching out his hand, the tiny body of the little robotic creature engineered by the Viridian emitted squawks that no one could hear. The Viridian needed no sound to communicate thanks to the floating satellites combing the dense toxic atmosphere of the planet and the engineering genius of the Viridian race. His body was equipped at all angles to connect within the far reaches of the planet Ekrondor. Sensors in his hands and feet translated to antennae sprouting from a novel helmet designed to protect his unnatural humanoid lungs from fumes emitted from toxic gases remaining from a historic cataclysmic explosion on Ekrondor that left the already hostile planet still today fuming with noxious gases and low gravity. The Viridian sat down on the nearby rock, protected from the acid surface of the outer armor of his hard skeletal shell. His curved and hooved feet, equipped to traverse the acidic, rocky terrain as easily as to wander through the Viridian metropolis, skidded against the rocky ground. Unless one lived in the rural communities or sought excursions in the rural outback of the Ekrondorian landscaping, it was uncommon for one to be so far from a Viridian community. This Viridian, however, had a mission: to scout locations in efforts to expand communities for further Viridian developments. A daunting task with fewer signals, less protections, and only he and Pei to protect themselves from the elements and the species' nemesis, their very own origins.
The Viridians were no normal race. In a primordial world, the Viridians were once an intelligent creature. Though formless and without senses, but a term of perceptibility, the species struggled to survive on a toxic planet, just barely inhabitable for life. And one day a treasure landed in their midst, a time capsule from futuristic rays on a planet known as Earth, containing human DNA, advanced technology, and resources for many forms of life to employ them. Capitalizing on what seemed like a gift from the heavens, the Viridians implemented the technology in DNA, manifesting their own race into a new species with humanoid features and engineering a suit of technological marvel to protect the failing species from the Ecuadorian elements, while enhancing the capabilities and senses of the Viridian body. For there was resistance to the development, those who chose not to transform using the human DNA were envious and sparked a revolution against the Viridians, who harnessed the human DNA spun in a great battle. After victory for the advanced species, Viridians flourished as never before. Their advanced technology allowed them to harness the planet's resources and tame its harsh environments. They developed sustainable energy sources, harnessed the power of the storms, and explored the depths of their world's oceans and the far reaches of space. In the end, unity prevailed over division as the unaltered Viridians chose to merge their genes and knowledge with their transformed kin. Viridians continued to toil with new technology and gadgets, forming iterations of what will become a supreme suit equipped to withstand the elements, augment their perception of their surroundings, and function as a living organism. Different individuals produce variations for heads starting with the humanoid skull as their base, dressing with gadgets, wires, and bearing helmets, until three wise Viridians collaborated together to form one ultimate production. They toiled tirelessly, introducing countless iterations of an exosuit that would protect them from their harsh environment, while also allowing for them to take full physical advantage of the terrain to move around without restriction. They topologically optimized the footwear with ultralight materials, gives them increased speed, great agility overall, especially in combat. Found in the Viridian body that glimmered with iridescent scales, suit enhanced the formless being with the musculature and a membrane structure encased with a soft exoskeleton cushioned inside of a hard exoskeleton. Hands that served as sensor and multifunctional appendage. Nuclear core that harnessed nuclear energy to fuel its technologically infused humanoid body and to maintain the body's temperature. Head attachment. Conjoined paired to the Viridian's body, relying on the Viridians as transportation will fuel him nuclear energy and providing comfort. Arm joined armor protects the Viridian from potential battle with kindred foe at the harsh elements. Cables to connect their advanced suit to their body. Gas mask to filter the air. Customizable feet equipped for speed and harsh terrain.
The species was not the only life form to emerge from the technological marvels. The Viridians also produced the creature Pei. Pei was not only the Viridians' most beloved companion, but a most essential component to the Viridian survival. Fixed to an attachment, Pei rode the Viridian as a backpack, charging directly into the Viridian energy core with nuclear energy channeled from satellites and the resonance in the environment from the nuclear explosion many years prior. Whether at his side or on his back, Pei traveled with the Viridian everywhere. As the Viridian sat, Pei climbed onto his back, squawking signals as he conjoined to the Viridian. The Viridian heaved a sigh through his gas mask, shaking off a tumbled volcanic stone captured in the curve of his foot that scathed against the acid rock. The curves were excellent for the high-speed cadence of the Viridian pace, and most excellent for the rough terrain, but certainly liked to kick up a lot of gravel. He looked out past the ooze of lava that spewed past the violet stream, flowing between the porous fissures in the ground, and saw in his mind's eye the building of a new urban landscape. In record time, what lay before him that appeared to be a barren, uninhabitable landscape would become an architectural wonder of futuristic structures and a transportation system that would one day whisk them effortlessly from one corner of their planet to another. And now, as the narrators of this incredible journey, we reveal our identity. We are humans, the architects of this experiment. While eons have passed on Ecuador, it has been less than one lifetime on Earth since we sent our time capsule. We watched the Viridians' conflict arise and resolve, witnessing their transformation from a species on the brink of extinction to world stewards. Our experiment succeeded beyond our wildest expectations, and we cannot help but to feel a profound sense of awe and responsibility for the role we played in their destiny. A capsule that altered their fate forever.
Thank you, guys.
Thank you.
Thank you. Super nice, like to see like chapter one's like work again, guys. Really, really fun. Seems that like you also like had like such fun like creating like this like movement throughout like the like the prosthesis itself and like how flexible it is. So you're good to go like for the VR lab, that's for sure. I wanted to ask you guys like again like the same question about like how you're doing, how you're feeling. Where are you right now, like after like chapter 2, especially like waiting like to start really like the like more intense part of chapter 3 with your educators? Would love to hear like your voices also.
Yeah, I guess I can start off with that. I think for me, coming from a background with really no experience in computational or procedural design, I think the program has been amazing so far. It's been incredible to learn all these different new programs and feel like you're really applying your skill set day in and day out. But I think the most important part to me, coming from a background of, you go to school and you learn the technology from one professor and you learn design from another professor, and there's not a ton of crossover there. And so sometimes it feels like there's a disconnect between what you want to do and what you're capable of doing, whereas in DesignMorphine, it's really amazing that all of your instructors are teaching you design and all of the programs, right? So if you have a question about how to achieve a certain design, how to implement something, everybody's more than happy to help. And it's incredible seeing the amount of involvement from everybody on staff who's always willing to help out students. And not even just help out, but they really want you to succeed and they want you to have the best project you can. So it's really been awesome so far.
I have to agree with everything that Braden said. And also, I think it's incredibly exciting the amount of knowledge you gain and skills that you learn in such a short time. At the beginning of this program, I was looking at everything we were about to learn and was feeling like, oh my gosh, I'm never going to learn this. And, in just after 3 months now, it's amazing to see like, oh my gosh, I can actually do this. This is happening. And that's, again, reiterating Braden's comments. I think, the staff is incredible and it's a really wonderful experience.
I can't hear you, Alejandro. I don't know why.
I'm sorry, I forgot that I have this one on too as well. So yeah, I can totally agree. I was fortunate enough to work for 2 projects in architecture. For one for Sahadid and another one for Adrian Smith and Gordon Hill. And at the moment, I didn't know how to like use like many of the tools that I know how to use now. And I was in a way like kind of like afraid of like even learning because I was like, okay, this is like complicated. It is just like something that I've never used before, and I did learn some of those tools like before the program, but what I can tell for sure is like based on my experience, like not only working in like this professional environment, also like learning from another program, is that this program like definitely gets like everything all together in just like one package, which is something that you're not really going to get like anywhere else. This is just one of those like experiences in my opinion where you can just like learn all the software that you're pretty much going to use like in any industry just like in one go. So like if you're not like really sure what industry you really want to work in, or if you're not like sure like what you really want to do like in design, or or even like if you already know what you want to do, but you're just like not sure how to do it, this is just like definitely the right program for you. So yeah, join us.
It's like the slogan now. Thank you so much. Yeah, like it's awesome to hear that you guys are enjoying it and you feel prepared for everything. And at least like you're seeing, like from the past years, these guys are applying it to everything. So you know, like that's good that like you're already like feeling like much more like you know, secure and like that you can tackle anything that comes your way, because that's, you know, that's why we created the program. Exactly, like this is what we felt that like was missing, and that's what we wish we had, you know, like when we were students and when we were like trying to figure out things, and we're still figuring out things, and we're still like, you know, changing and going into different spaces. So you know, it's one community, so it's great to hear, guys. Thank you. We can move
Thank
on to the next team. We'll have chapter 2 now, a little bit of a different scale of operation, but excited to see that scale too. Thank you, guys.
Hello, everyone. Can you hear me well?
Yep.
Cool, cool. I'm sharing my screen now. Is it all fine or?
Yep.
Yep. Oh. Hello, everyone. We're Group BO1. My name is Cesar Requejo, and I'm an architect from Peru.
Hey everyone, my name is Cassio Tani, and I'm an architect from Brazil.
Hi everyone, my name is Diego Guerrero and I'm an architect based in Ecuador.
And we are here today to present a project called Symphony of Symbiosis. So let's get started. In the heart of lush radiance, the Etherians, an advanced race, coexist harmoniously with the planet's ecosystems. Shaped by natural selection and propelled by biotechnology, they boast a collective hive mind for unparalleled coordination. Their quest for moonstone, vital for survival, leads to the creation of the synthesions. Initially designed for harvesting, these creations rebel, sparking a cosmic conflict. In response, the Etherians deploy biotech defenders to safeguard their existence in low orbit. This epic saga explores the intricate dynamics of the Etherians as they navigate life challenges in the unforgiving low orbit around Radiance. To endure Radiance's challenging low orbit, the Etherians can transcend into high faults, massive living structures strategically positioned for harvesting precious moonstone. Stored within this invaluable resource not only powers their being, but also sculpts their ever-evolving forms shaped by the demands of survival. In this advanced stage of bioengineering, the Etherians showcase their mastery, seamlessly merging with Radiance's ecosystem for harmonious coexistence, transforming their bodies into the next evolutionary step, the hyphal. These energy-demanding forms acts as a protective layer, transforming elements within the Etherians for the hive's needs. Evolving in response to the environment, it adapts to low-orbit gravitational variations.
These interconnected systems, vital for functionality, ensure the hive's hold survival in Radiant's low orbit. A complex skeletal system works as support structure, giving the body its shape. Developed muscles maintain the hive's hold integrity, interconnecting rooms and allowing light to access. Growth facilitates communication among hive members, ensuring seamless information flow. Veins capture, store, and redistribute moonstone energy, sustaining life and energizing the entire hive. A secondary layer in the skeleton fortifies extremities, shaping rooms and providing protection. This intricate biology results in a massive structure ready for interstellar conquest, an icon of evolution and biotechnology. At its core, there's a central nucleus that radiates hallways, forming a network connecting various structures. It's called the Plaza of Convergence, which serves as a central gathering point for the Etherians. The moonstone repositories keep harvested moonstone and safeguarded in ideal conditions. The breeding chambers nurture and protect eggs until they reach the full developed stage of Etherians' bodies. The rejuvenation nexus offers a comfortable space for Etherians to rest, recharge, and also meditate. The crystal atrium, the evolutionary metamorphic, and the biotech nexus meet corpuscle needs by processing moonstone, guiding Etherians through life cycle stages, and enhancing biotechnology in advanced labs. In the Moonstone repositories, we can find the inner flux conduit. It is a storage and processor for the Moonstone, irrigating the veins with energy and allowing the flow through the whole hive hole. In the rejuvenation nexus, we can find the etheric mandolin. The Ethereums can attach themselves to and recuperate from any injuries in their bodies. Lastly, in the breeding chambers, we can find the ovum nexus core. It is specialized in procreating and taking care of multiple eggs. These eggs are attached to the energy conduits, allowing them to grow into the next stage. The hive hole is not just a mere shelter, but a living, breathing entity, intricately woven into the hive's collective spirit. This colossal structure, while serving as the sanctuary for the hive denizens, is no passive observer. It pulses with vitality, similar to a colossal organism, actively participating in the hive's communal heartbeat. The functionality of the energetic veins coursing through the surface of the hive hole begins in the inner flux conduit. These conduits irrigate the veins with moonstone-derived energy throughout the entire hive hole, all crucial for survival and prosperity of the entire species.
The hivefold entwine their bodies, enabling quick responses and coordinated efforts for emergencies on a larger scale. This facilitates efficient sharing and processing of moonstone energy, with connection variations defined by spatial occupation and aggregating shapes. The vertical groupings are called altitude nexus. The horizontal groupings are called horizontal confluence. The radial groupings are called trilateral synapses, and the diamond groupings are called tetraphase nexus. These groupings of hivefolds connect between each other and build the entire hive ecosystem around the planet radiance. The inner structure of the hivefold allows a seamless connection between the plaza of convergence and the rest of the rooms. This intricacy of spaces allows quick interactions between rooms and helps with a seamless flow between members of the hive. Since the hivefolds exist in low-gravity environments, the inner structure of the rooms varies in axis, being defined only by faint architectural vestiges that define the rooms. The exoskeleton and muscles form a protective shield around the hivefold, defending it from external threats. Moonstone-energized veins irrigate the body, connecting with the hive's energy network. Specialized communication structures grow, enabling hive members to exchange essential information. As the growth expands, it crucially facilitates the breeding chamber. Eggs communicate energy needs to the ovum nexus core through the intricate network, ensuring precise and coordinated egg development for the flawless continuation of the Ethereum life cycle. As we draw the curtains on our extraordinary exploration into the enigmatic realm of the hivefold, we find ourselves spellbound by the symphony of interconnected structures and the pulsating heartbeat of unity that defines this extraordinary collective. The hivefold's architecture embodies cooperative ingenuity, seamlessly fusing organic design and communal synergy. Every element, from vital energy-carrying veins to communication-facilitating growths, plays a crucial role. Until our next journey, we're captivated by the hivefold's majestic odyssey in the cosmic tapestry. Thank you very much.
Thank you very much.
It was really amazing, like seeing your work again, guys. Really fun. It's basically the building block for your next chapter. So it's going to be super interesting to see like how all these formations are really coming together and creating a society. I wanted to ask you the same question. I'll ask all the teams that are here with us today. How are you feeling? How are you doing? How are you enjoying the process? I know that you guys have like a similar background, so architecture, like, and you know, like Latin America. So like, I'm interested to hear like how you guys are rolling like through the program.
I think so far this perspective and singular way of thinking we have in the program like really encourage us to think outside traditional boundaries. Like I said, like we come from architecture background, and I can tell like this approach of challenging existing norms and assumptions, we totally develop a more diverse and unconventional solutions to design problems. So it's really fun and it's really important.
Yeah, also it has helped us tackle the design problems in a different way, because as we have the same background, we decided not to go with any orthogonal stuff, as you have seen. So it has been really challenging, but really fun at the same time. And I'm talking about like interacting with ourselves in the group and with the tutors, with other students, because everyone has a different background, everyone has a different approach to design. So it's super cool to learn how people tackle the same problem, but in like 1,000 different ways. So you're always learning. You're always learning like design techniques and the software, of course. And it's been super great for me, especially to learn new techniques with parametric design and algorithmic wizardry. So I'm excited to see what's to come, and I'm super grateful for this opportunity.
I would say that I'm also very happy with what I am learning from the masters, because something that is really important here, I'd say that it's use the computational tools to design, which they don't teach you conventionally, at least not in architecture school. So it's different designing with the help of the softwares. I mean, the tools always shape the final result. So these different softwares are tools as well, and help us approach our ideas, help us understand our own design. And of course, working in a team means that you're not alone. So we are, I am very happy with the team that I have, because we also help each other understand stuff. And of course, the tutors also guide you through the whole process of understanding not only the software, but also your own language, which is sometimes hard to find, but it's very cool. It's been a long journey since now, and I am very excited for what's to come. So that's it. Thanks.
Thank you, guys. Yeah, Cesar, like it's what like Michael was saying, like that it's our, like we're all in a way like to hold you accountable to your own ideas sometimes, like because there's so much you can do, and like you're imagining the constraints alongside with the language that you're, like going after. So I think that that's where a lot of the challenges are coming, because like you need to have this, double like role in a way, like constrain yourself, like working with an environment that you're creating, and then like following through and like scaling up with the same language. So definitely something that like it's not a conventional way of thinking, but I'm happy that you guys are really like enjoying it, and you're having fun also like as a team and learning together and helping each other. So that's great. Thank you.
Thank you.
Thank you very much.
More chapter 2, and we're going to have more chapter 2, like, so it's super exciting to hear from Mansoor.
Are you seeing my screen?
We are, yes.
Okay, cool. Well, hi everyone. Thank you, DesignMorphine, for the invitation. My name is Mansoor. I'm an architect and an artisan based in Bogota, Colombia. I did this project along Inayat Kabir, who's a motion designer and a lighting designer from Bangladesh. Amenta. This is a tale of cyborg shamanism, delving deep into the essence of entropy and the intricacies of harmony in a world that straddles the spiritual, the digital, and the spectral. Enter Amenta, a realm that exists at the crossroads of the spiritual, the organic, and the cybernetic. Where eons ago, when Earth was still young, a cataclysmic event imploded its reality into another dimension. This fragment, infused with a mix of Earth's natural energies and the digital potential of the new dimension, evolve over countless millennia to become Amenta. Within Amenta, there is the Nexus, located in the core of the largest floating continent in this realm. The Nexus, a seemingly bottomless body of liquid code, holds encrypted within it all the histories that have ever been. The Council of Elder Shamans guard over the Nexus, protecting the inhabitants of Amenta with access to knowledge of light and conversely shield them from dark knowledge. Lumaya, one chosen by the prophecies of Elder Shamans, has come of age and is about to go through a sacred initiation ritual. Lumaya's initiation into shamanhood takes an unexpected turn when the ritual results in the emergence of Akito. His existence, an uncharted blend of fragmented souls, digital code, and dark energy, threatens to disrupt Amenta's fragile harmony. As Akito rapidly gains followers of his own, the elders task Lumaya with responsibility of bringing balance back to Amenta by purifying the aberration that is Akito. Little do they know that the fate of Amenta hangs in the delicate balance hinging on Lumaya's ability to meld the infinite knowledge held in the Nexus, with Akito's forbidden insights of ancestral histories long past. In the absence of darkness, there is no light. Deep in the shadows of Amenta lies a hidden monastery shrouded in darkness. This sanctuary, veiled from prying eyes, harbors Akito's followers, a sect of shamans devoted to decrypting forbidden knowledge and the darkness of the long-forgotten past. Angular rock faces evoking the ancient glyphs and digital circuitry form the core of these structures. Held together by brides forged from ores harvested from forbidden realms that once crossed Amenta. Wrapped around the ruins are intricate skeletal structures forged from the same rare ores and imbued with Amentan consciousness. These serve various functions through their shape-shifting properties. Harnessing the flexibility of the shape-shifting armature, the puzzle forms of the ruins, and the energy held within the bridges, these dwellings reconfigure to suit the needs of their environment. At the heart of the monastery lies the decryption hall. Here, Akito Shaman's followers dedicate themselves to the decryption of forbidden dark histories hidden from the depths of the Nexus. These practitioners walk the delicate line between light and darkness, seeking understanding beyond the boundaries of that which has been taught by the elder shamans who watch over the Nexus. Within the Salem Hall, a single sigil floats over the altar's platforms, serving as the core of the decryption hall. Each sigil, meticulously crafted and imbued with mystical energies, holds within its refractive form a direct connection to the Nexus. This allows our shamans to circumvent the safeguards of the Council of Elder Shamans who watch over the Nexus and provide them access to the forbidden knowledge of the past that has been kept hidden away until now. Akito's followers gather around these floating sigils, each using their own spiritual interfaces to pull fragmented knowledge of the past into their consciousness. Through intense meditation and disciplined introspection, the initiates seek communion with the darkness of the past, delving into the depths of their subconscious minds to decipher and reconstruct the hidden wisdom veiled within the fragmented histories held in the Nexus. The followers spend years decoding this fragmented knowledge, unlocking layers of understanding that transcend the boundaries of Amentan consciousness, all while navigating the inherent dangers of tapping into such forbidden realms of insight. Each follower's quest for enlightenment hinges upon their ability to decode the cryptic visions cast from the sigils, tethering along the edge of chaos and harmony. At the top of the monastery is the conduit to the nexus, a serene and shimmering pool nestled within the monastery's depth, where shamans immerse themselves to return their visions and insights into the nexus. Sacred waters within this secluded enclave serve as a gateway for the shamans to commune with the nexus. Here their reflections on the pool's surface unveil prophetic visions as they return the knowledge they have decrypted back into the nexus. Here we see Akito about to initiate the ritual. Dimly lit from the glow of nexus nodes that strengthen the connection to the nexus. With Akito aiding their connection to the nexus, one of his followers returns the once fragmented knowledge that they have deciphered and made whole again back into the nexus. The Vision Quest platform stands as a sanctum within the monastery's ruins. Shamans seeking enlightenment embark on a profound journey within this chamber, consuming a potent elixir brewed from rare herbs and infused with mystical energies. As the elixir takes effect, the chamber becomes a shape-shifting tapestry of swirling hues, transporting the shamans into the labyrinth of their subconscious minds. Garden of Decay. This dark but serene sanctuary within the monastery honors the inevitability of death and the necessity of acknowledging decay in order to appreciate the beauty of the living. Here, shamans contemplate the transient nature of all existence, embracing the darkness as an integral facet of life itself. The monastery's chambers of solitude serve as sanctuaries for the shamans' introspective journeys. The story of how Lumaya and Akito come to understand each other is one for another time. For now, we look ahead to how the merging of their darkness and light came to reflect itself across all of Amenta. Here we see their respective monasteries merging together in harmony. Thank you.
Thank you, Mansoor. Thank you. It was very nice seeing the presentation again and like having like all the storytelling. I love like, you know, like how cryptic everything is and like how you're like tying it together. Like it's really amazing story and very unique. I want to ask you the same question. How are you doing? How are you guys like you're rolling into like chapter 3? Like, are you excited for the next chapter? Like starting now, like also like on Monday, like with the tutors.
In regards to the chapter, yes, it's one of the chapters I was most looking forward to in the program. The fact that taking a module and aggregating it to create these like environments or these worlds was very interesting to me. And also a skill that seems very scalable in different industries, obviously architecture, but I don't know, I like to do ceramic work. I see some applications in ceramics as well. And yeah, that in regards to the chapter. About the program, it's been challenging, but the fact that it's been challenging, I feel it's made it more worthwhile. I think that tough journeys, you know, lead to great victories or like great places. We've seen that in the previous alumni. So it's yeah, like it's been challenging, but extremely worthwhile. And comments about the program, yeah, like the multidisciplinarity of our tutors, of our mentors, and also of our fellow students, like just adds a good mix of content from various backgrounds. I think Oscar also mentioned before that there's this like two layers of stuff. There's like the technical aspect, and then there's the conceptual aspect of things. And there's people that are, you know, better at one than the other, and like you feed off of everybody's like fortes, let's say, in these different areas. And yeah, basically that's what I have to say for now, I'd say.
Thank you so much, Mansoor. It was really wonderful seeing the work again. Perfect.
Cool. Thank you very much.
Thank you. We have one more team, last team for the day. And we're excited to see again like the work from chapter 2 from you guys, like, and you know, hear a little bit of your perspective. Thank you.
Yes, I will share my screen now. Okay. Can you see my screen?
Yes.
Okay. Good evening, everyone. I'm Salma Ghanem. My teammates are Yatsik and Janosch, and we're presenting the synaptic conflux from the character's point of view. In the aftermath of Earth's cataclysmic event, the explosion of Earth's core, I, the fragmented oracle, emerged within the synaptic conflux, a celestial mosaic formed from the remnants of our shattered planets. Survival in this unforgiving expanse demands constant adaptation, resource mastery, and collaborative evolution among our network of AI beings. As the fragmented oracle, I embody both exceptional intelligence and profound connection to our collective consciousness. And by my side is Echo, my gecko companion, a skilled scout and communicator. Our habitat's architecture unveils an intricate array of controlled environments, meticulously designed to serve our diverse needs. These specialized units double as both training grounds and innovation centers, allowing us to refine technology and strategies to thrive across varied terrains of the fragmented cosmos, as we are not alone in this cosmos expand.
My unique appearance features a fusion of organic elements and advanced technologies. The layering begins with the mechanical core, upon which the organic base, system of veins, the protective calcium armor, energy storage units, and finally, the crystalline communication horns are all precisely integrated. Echo's composition mirrors mine, featuring the same layers. Notably, Echo possesses an additional layer, distinguished by sensory horns on his back. These tiny horns enable him to scout new terrains for essential materials, facilitating our survival and unity in the cosmic chaos. In our expeditions across the fragments, gathering materials often intervenes with encountering other cosmic entities. In this cosmic ballet, injuries are an inevitable outcome. Therefore, our solid bases and habitats, seamlessly integrated into rocky terrain, serve as our sanctuaries and strongholds. In these fortresses, we forge our resilience and solidarity among the lawlessness.
During a recent expedition, I encountered severe injuries while engaging in a struggle for rare metal on fragment 2011. The retreat became imminent, leading me back to our corpuscle, our primary habitat. Similar to the fragmented oracle, our habitat is an intricate web of layered fortification. A calcium shell protects the organic layers housing our primary spaces. This shell, reinforced with metallic elements, emits a soft, glowing aura that an identifying beacon amidst the horizon. Its curvature creates deliberate gaps, openings, crafted for essential access. Inside the shell is the primary organic base, the heart, where the oracle's interaction unfold. Veins of supply encircle this base, pulsing life-giving energy through our organic matter. Finally, the energy chambers stand as repositories not only for recharging, but also for healing in vital spaces, where injuries find solace in repair.
Within our living units, each space is meticulously designed, considering our survival as paramount. To ensure optimal control over our environment, each unit is accessed through a single entrance. Adjacent to the entry point is the transportation dock, housing our vehicles and supplies retrieved from expeditions. Deep within the corpuscle resides the interior core, placed strategically at the center. The mechanical core serves as the corpuscle's nucleus. The energy is carefully channeled by the mechanical core through the supply veins catering to different spaces. Primarily, it converges towards the energy chambers, crucial respiratories used for recharging and healing. Following this is the unit production wing, where the fragmented oracle units are fabricated, with both mechanical cores and organic sleeves constructed. The resource storage stores the fruits of our expeditions, while the farming lab stands as a bastion of experimentation and growth. We experiment and produce different species of plants that will help us expand our world and ensure our survival. Some are submerged in energy, and others are less sensitive and require less care. Finally, we reach the energy chambers, havens of rest and healing. The inside of the chambers is always packed with other fragmented oracles who need recharging. For significant injuries like the one I sustained, the primary cocoon inflates with energy, providing a sanctuary for organic matter to heal. Others among the fragmented oracles utilize recharging chairs, while Echo 2 finds respite in recharging in his pods.
Cutting through our corpuscle, you can notice the reinforced feeling of the armor structure, which is the bone marrow of the calcium armor. The section emphasizes the protective role of our shielding layers, enveloping the spaces to safeguard our species. With the core nestled at the corpuscle's center, it achieves maximum range to every corner of the structure, allowing seamless energy distribution. Storage units are situated around the periphery, allowing them to expand or contract based on the current energy reserves. The plan illustrates the placement of different functions in relation to each other. It outlines the flow of space around the farming lab and the storage units around it. The veins in the core area are much thicker and carry energy around the corpuscle, distributing by need and acting like the main arteries supplying for survival. As beings integrated into a hive mind, our existence revolves around collective societies, fostering interaction to ensure the well-being of our species. Our units, designed for structural support, have the unique capability to stack vertically. Additionally, the extended arms of our calcium armor can interlock, facilitating horizontal expansion, emblematic of our unified growth.
Our journey through the synaptic complex is a testament to unity, resilience, and innovation. As fragmented Oracle and Echo, we thrive by embracing challenges and growing together. Our story is one of the teamwork and adaptability, showing that even in chaos, our unity is our strength. Together, we paint the future where collaboration reigns supreme among the stars, leaving a legacy of harmony and unity across the cosmos. In our collective hive, every single eye gazes towards the same horizon. Every single muscle contracts and expands in unison. And every single bone supports and moves in harmony, all dedicated towards a common goal. Thank you.
Thank you. Amazing presentation. Thank you so much for sharing it with us again. It's always like amazing to see like the progress and like how you guys are doing. Excited for the next steps for you guys. I'm also like curious to hear how you're doing. I know like that again, like some of your backgrounds haven't been again like in computational design, but rather very different. So, you know, like again, like being from different countries, different, you know, like paths of life. I'm curious to hear like how you guys are feeling and how you guys are doing, like now that we're past the first semester of the program.
So for me, I do have a background in architecture, and it's really hard to learn these kind of skills where I am, which is I'm based in Cairo, Egypt. And to me, I was just trying to find a way to learn these kind of computational skills and apply them. And I think this program is perfect for that, because you learn the skill and you can apply it on multiple scales: the scale of the character, the scale of the corpuscle, and then there's the scale of the amalgamation and the world building. So I think like I'm getting exactly what I wanted from this program, which is I'm happy about.
So, as an addition to what Salma said before me, I'm really happy about this program. Simultaneously to this program, I do my master thesis in architecture. So I'm studying both together. So it is requiring for me some sacrifice regarding the time management and prioritizing some stuff. But so far so good, I could say. And the skill set of ours, especially speaking for myself, when I joined the program, I didn't know much besides some basics in Grasshopper and Rhino. So our first week in Maya was horrible. But since then, if we take a look at the work in progress boards from the first week, we can see how greatly the program influenced us and how greatly we did progress. So the fact that we still have contact with our tutors, and whenever we require help, they are there for us. And it's not the type of the program that we do whatever professor wants, but rather we are doing something we want with the help that we require is a great thing. And I would definitely recommend this program to absolutely anyone.
Yeah, and when it comes to me, I finished engineering degree in architecture, and I wanted to deviate from the architecture industry somehow. Then I found this program, and so far I can easily say that it opens doors to many different industries. For me, it's kind of perfect actually, because I'm not really sure in what industry exactly I wanna lose myself in, and this program teaches you like the base skill of many programs that you can later focus and master in different industries. So it really like is very easy to get into in these terms, and also you're not really like declined to get from one industry to another. Like changing jobs, I heard in this environment is really pretty easy. So yeah, I can recommend.
Thank you, guys. Thank you so much for presenting and for sharing your thoughts with us. It's been amazing, like opportunity, like to see the work once more. And yeah, like I think that now we can open up like the basically like the portion of like, you know, being able to answer any kind of questions from any guests that we have or anyone who has questions about like any part of really like the program. So we're available. Let us know. You can write on the chat if you have any questions, or the Q&A portion of you know, like here like in Zoom, or you can, you know, just let us know if you have any questions like throughout the open day. We have added Blender to the program. I see a question from Diego Martinez. We have added Blender into chapter 3, so that's what the guys are using it. We're using it again like as a generative tool, so it is like part of the curriculum now.
Yes, it's being taught by Laura. They're a little shy today, but also to remind, if you have questions in the future, you can reach out and schedule a one-on-one also.
Yeah, there is a lot of like information online, and also I know that now, like being the third year, we have like previous like open days that are, you know, like easy to see again, like the curriculum and how things are really working. But again, like if you have any questions or like they're particular to you guys, feel free to also like schedule time like with me on a one-to-one. I see like Diego has another question. Do you think that it's possible to use Blender as a substitute to Maya? Well, I know that some students have. It's not that they haven't, but we do encourage you to learn the softwares that like we are, you know, here to teach you and to support you with, because as we said, like the educators have this dual role where they guide you through the design process, help you, you know, like with your ideas, but also like they are there to support you technically. So as the chapters are like building up, like Maya, it is an industry standard software, so it's actually like a great one to know. The other thing is that if you know Blender, it's pretty easy to learn Maya, and vice versa, right? Because they're the same logic, like polygonal modeling, like softwares.
Yeah, to echo on that, I mean, polygonal modeling is polygonal modeling wherever you do it. The reason why Maya is so important, like Pavino said, was because of industry standards. And so when you're thinking about going into the workforce for a career, a lot of offices are going to be using Maya just because it's been so kind of embedded into their systems or their workflows. So, it's important to kind of know the software of, these places that you'll be working. For instance, like the film, film industry, for instance, like that, or game industry, if we're talking like big AAA studios and that, they're going to be using Maya just because like, it's not because they can't use Blender, it's just that like the way that they're set up and the way that their office and workflow has been set up is all through Maya. And it takes a lot to change like an entire company from like the standards of what they've been doing for years and the plugins they've built and all this stuff. So that's really the reason why like a lot of these softwares are still very important to know, even though as new softwares come out. So you have a question from David. He wants to know, if I apply on February 1st, can I still engage in the design assignment for the scholarship?
Of course, yeah. Yeah, it's just that the deadline is the 1st of April, like for the scholarships, but that means that you can apply earlier, like as early as, like as now. Like the good thing about the February 1 deadline is that there is a discount like for early application. So in this way, you can apply for the scholarships and you can apply for the early bird application, which is great. Like we do encourage it. However, you will probably like hear back like after the 1st of April application, because that's where we're going to review like with the rest of the DesignMorphine team, like all applications, and come back like with all the offers for the scholarships.
Yeah, and I think I would say like if you're thinking of joining, it's definitely better to apply by that February 1st deadline at least. So in case you don't get the scholarship, you still at least get like the lower tuition, kind of lock that in.
Yeah, that's helpful, definitely. The scholarships now are too, so I know that like a lot of people are preparing, especially because it's now, like for one of the scholarships again, like you need a portfolio, which is, like it's not very difficult, like for, like any creative field, but then like there is the challenge, especially if you're applying for the Dream Big scholarship. However, I would say like be creative. It's important like to show your personality, like your design ethos. I think that's the most important thing that we're looking for. We're not looking for, like a computational design specialist at the end of the day, but we just want to see your personality shine.
That's important to mention. Like no one that joins is like computational design specialist. I mean, if they were, they wouldn't be joining, right? They already know. So don't let that be anything that makes you kind of like afraid to join. you know, 98% of people that join don't know any of this stuff, I would say. And they're learning this as they go and becoming, you know, experts as they go, and getting, you know, jobs with these tools at the end of these months, which is just incredible. So, yeah, most people don't know much of any of this software. Probably these guys here that are just presenting, a lot of them didn't know a lot of this stuff jumping in. So it's not as scary as you might think.
Yeah, it's even sometimes it's actually better because like it's you know, like more open-minded. Like if you know somebody's just more open-minded to just go through the program and like go step by step through the process, it's much easier than thinking that like they know, you know, like certain things, because like it is an educational process, as we said. Like it does work like stepping stones, right? Like so it is important like to take on like each and every one of the steps. And I think that like you're able to appreciate the whole educational journey when it finishes, because it is, you know, like so intertwined, and it does like, you know, scale up like in scale, but also in complexity as you're moving forward. But also like your skills and your, you know, just ability to trust in yourself, learn, experiment, problem solve, like all these things are really growing like as you also like move throughout the program.
Yeah, and you know, it's you know, we're again like there's so many educators, you know, available around the clock, so we're always there to help and always kind of actively engaging. So as these students will tell you, so you know, there's no worry that like you're going to be lost. Everything is very structured, and we're really, you know, just there to help you. Also want to mention real quick, aside from the one-on-ones that you can set with Pavlina, you can also reach us at masters@designmorphine.com. Any emails you want to send, if you're more comfortable that way, masters@designmorphine.com. So David's saying, can all my graduate docs, diploma, and transcripts be submitted digitally with my application?
Depends on the country you're coming from, like in the legal processes. So what you're doing in the beginning is you're just taking a photo, basically, like of your like the transcripts and your diploma, and we're reviewing it and coming back, like with like specific, you know, like each, like when you're getting your conditional offer, basically you're getting like very explicit directions of how exactly you need to submit everything. But yes, in your case, normally, like from the US, the rule of thumb, I would say that like most candidates are able to submit online, like their, you know, like transcripts.
It depends on the documents. If your documents are digitally verified from your university, then you can submit it online for the US.
Clark is telling David also that he asked his university to send the PDF
Yeah.
directly by email. So this is another.
Exactly. Yeah.
Yeah.
This Clark is again from US, and yeah, in his case, usually for the US it works that way, digitally.
Yeah, it's usually even on their website. Like you can request
Yeah.
your information to be sent somewhere, like officially, like through your past university's websites.
Yeah. Sometimes these universities, sometimes they send us digitally the document, sometimes they directly send it by the post, physically. It depends on the university.
Yes,
Is there any other questions?
he's asking, I have a scan of my diploma. Will that work? I would say apply, just put everything that you have, and we'll review like your particular case, and we'll come
Yeah,
back to you.
just send what you have, and if we need something, we'll just ask for it. If we need something a certain way.
It doesn't need to be perfect. Like the documentation phase is like a process. So just send what you have, like you know, like from transcripts and that documents, and then like we'll we'll send you all the necessary information like for your specific case.
Yeah, we'll never be like, oh, this guy, David sent his PDF the wrong way. We're not gonna take him as a student. Like no, it won't be like that. Don't worry. If something is wrong, we'll figure it out and we'll ask, the right way to get it. Yeah, any other questions? No. If not, I think we could end this open day. And of course, this is recorded. It will be on YouTube and we'll send the email so you can review it and watch it as you see fit. And we thank you all for joining. And thank you all past and current students who also attended and joined and interacted today. It was very helpful, and we thank you so much for your time.
Thank you, guys. It was wonderful to see you again. Like, it's really amazing, like, to be part of this community and for hearing, like all these great stories about, like, how also like our alumni are doing, like see some faces from last year, see some faces from this year. It's really amazing. And I'm hoping that soon we'll have more information about like where we are meeting this year, because like we normally like also include like some of our alumni are joining us. So in this way, like you're able to, meet each other and, like create like this community that we're having. Thank you so much, guys. It's really wonderful. We appreciate you.
Thank you so much, everyone, for joining.